Welcome to the Generative Edge, the podcast that keeps you up to date with the latest news and events in the world of generative AI. I'm Stephanie, and I'm a consultant at Deloitte Central Europe.
I'm Brandon Eichner, and I'm the Natural Language Processing and Generative AI Practice Lead for Deloitte Central Europe.
And today we are going to talk about what we just said, the latest news and events in the world of generative AI. Because I don't know about you, Brennan, I know you work in this industry all the time, trying to keep up with all of the news and all of the technological innovations that are happening in generative AI and in the AI space.
Yeah.
Honestly, it makes my head spin. And
it's crazy.
We are literally making a podcast trying to cover all of these things.
Yeah.
So I would love to just ask you outright, what is the coolest thing that you've heard about, at least at this moment, time of recording? We're actually filming this in, mid-August?
Yeah.
So 2024. So what is the coolest thing that you've heard about in the last few weeks in Gen AI?
I would probably say the optimization of large language models for mobile and edge devices.
Oh, wait a minute.
Speaking of the generative edge.
Yeah.
Right. So I watched Google's technical talk, I guess, a week ago when they were releasing the Google Pixel 9 line of phones, and their announcement about Gemini, which is their product that's based on large language models. And I was really impressed, actually, that basically they've made updates to the processor on the phones, and they've made updates to their large language model such that the language model can actually run on the phone itself.
Oh, wait a second. Okay.
Which, if you rewind a year or so, it was thought to be basically impossible.
Right.
Something that has enough performance to be a co-pilot running on something as small as a phone is crazy to me.
Okay.
So I guess I would say that's the coolest thing in the last couple of weeks.
So when you say it's on the device, is it, I don't know, connecting to the cloud? How...
No, it's
how does that work?
Yeah. So it's a multimodal model, which means that it can take in audio, pictures, so screenshots, what's on your screen, documents, files that are on the phone, and what I assume is happening is that all of that is built into some kind of on-device RAG system. RAG means Retrieval Augmented Generative System. So it's breaking everything up into chunks and then using that as context. And, yeah.
It's what a lot of the chatbots nowadays are
yes.
running on.
Yeah. We've definitely covered it before. So basically, it takes in all this information and it uses that to complete tasks. So you can talk to it and it will put things into your calendar or send reminders or send messages or read emails or summarize things. I mean, all the things that we typically use generative AI for as consultants, except it's just on a phone and it doesn't even need to touch the cloud. So,
Wow.
Some of those features, I think, if I remember correctly, the image processing, that's the cloud-based, but there are lots of features that actually run just directly on the device, never send your data away from the device. And that's basically the impetus behind it is people want to have these co-pilots, but they also are concerned about data privacy. They're concerned about who has access to their data.
Yeah.
And the less data that you're sending to the internet, probably the safer,
Yeah.
probably the better. So I think it's a really exciting innovation. I wouldn't have predicted it a year ago. Now it seems almost inevitable that we will all be running phones with little co-pilots on them.
First of all, that's awesome. I'm learning about this for the first time, which is great. So in that way, so I'm imagining just how I use my own smartphone on the daily. My understanding is large language models are in fact large, right? And I know you mentioned multimodal, so of course it's able to do lots of different things. So is this an example of a small language model running on a phone, or how would you describe that process?
So the details aren't super
proprietary.
Yeah, they haven't been published in a technical paper yet. If they are in the future, then I will definitely let you know. But what I assume is happening, there's many different things you can do to make a model more efficient. One of those would be model pruning, which is another thing that's been in the news recently, especially around the llama family family of language models. For those of you who don't know, Llama is just like an open source. It's from Meta. They call it a herd of language models,
which
I think is super cute.
That's really cute.
Yeah. So model pruning, if you can imagine a model as like a stack of calculators, right? But actually each one of those calculators is called a neuron. And if you take out a bunch of neurons, then it's left with a bunch of holes. It's just like layers and layers and layers of neurons. So pruning is taking out entire layers or specific neurons in each layer to figure out whether or not the model is going to continue acting the same way. If you imagine like taking a person's brain apart and like seeing how well they function as a person, the more of their brain you take away.
Wait a minute. Are we lobotomizing language models?
Kind of.
What's happening?
Yeah, kind of. But it turns out that it works really well, actually.
Oh, that's cool.
So they're much more efficient. It turns out that they only lose a little bit of, depending on which layers you prune. You figure out which layers to optimally prune, remove all that compute necessary to like make it past that layer, and they can go faster. They can do almost the same thing. So if you imagine taking out like half of the neurons or something and still preserving 80% of its cognitive ability or whatever. So that's one thing. There's also something called quantization, which is so all the calculations that are done by large language models are typically done on like float numbers. I'm going to try not to get too technical.
I was going to say you might need to explain float numbers to me.
Yeah.
But
so every piece of information in a computer needs a specific amount of memory in order to hold it. So you refer to float values, which are like 1.5, 1.6, 0.2. Those are float values. And they can be encoded with like 8 bits or 16 bits or 32 bits. They're powers of 2, right? So, and obviously a 16-bit float is going to take up more memory than an 8-bit float. So quantization is taking all these calculations that are done by the large language model and the infrastructure that it's running on. Instead of calculating everything with 32-bit accuracy, we just reduce that to 4 bits. So there's a little bit of information loss. It's not quite as powerful as if you were being super precise with 32-bit floats, but you've reduced the necessary compute by a factor of like 16 or something. So model pruning, quantization, there's a couple others, but I don't want to get maybe too technical on today's episode.
But I think like all these things that you just mentioned about quantization, if I'm even saying it properly, model pruning, this is all to make these language models, so not even small, large, whatever size language model you're using, to make them more efficient for the task at hand, right? Okay. So I know that as we've been going through researching for the show, I came across this term called prompt caching.
Yeah. Oh, yeah. Okay.
So I think it's slightly different from what you were just talking about. But where does this prompt, first of all, what is prompt caching for our audience? But then where does that fit into this equation as well?
That's a good one, actually. So prompt caching, so for those of you who have never worked with large language models before, you basically have a context window in the beginning. That's your input. So, you type
You're actually typing the stuff.
Exactly. Type out whatever you want, give it the information it needs in order to complete a task, and then that goes into the model. It does all the calculations, and then it predicts the next word over and over and over again so that you have a nice output. So whenever you send that input context to the model, it's starting from scratch every single time. It needs to load all of those words into its memory. It needs to do a bunch of calculations, figure out how those words are related to each other, and then run the calculation all the way through to the end. The prompt caching, this is taking whatever prompt you've sent, but then putting it into the memory of the large language model, or basically caching what the initial state of those calculations is, so that you don't need to do it every time. So this is super useful for use cases where maybe it's like a chatbot, or it has a specific, like the large language model has a specific task, and you've given it a system message of, you are a large language model, you write summaries for blah, 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 but you also follow these 275 rules. So that system message is really, really long, and you have to pay every time that you insert a token into the model, right? Prompt caching basically takes that entire prompt, and instead of making it process them all the time, it just loads it directly into the memory of the model, and then you don't have to spend the money to use that system prompt over and over and over again. In some cases, I think it's like a reduction in price by like 90%. Of course, it's controlled by the people who are actually like making the models commercially available, but it also reduces compute. So if you were using it like in an open source way on your local computer and you cache those tokens, you've automatically reduced the amount of compute necessary to actually predict tokens and
I
stuff.
would imagine not only are there cost savings, but there's probably like energy savings as well, because you're not literally starting from scratch every time. So it takes less energy to use.
Yes.
Is that a fair thing to say?
I would say so, yeah. Because
Okay.
every calculation requires some amount of energy. I don't know how
we
much
won't
energy.
quote numbers,
I won't quote
exactly.
numbers, but there's definitely a reduction. So
I do want to ask you, because like you said, we were researching for the show. I do want to ask you about this thing that might be slightly controversial. I've seen examples of AI generated books, digital ebooks, that maybe are not exactly factually correct or something like that. How is it possible, other than, I mean, through painstaking work, it sounds like, to literally write an entire book that's based on generated content? It seems a lot to me. Is that easier to do now? Because these stories of these AI generated books seem to be popping up a little bit more nowadays. So is there a technological reason for that? Or?
Yeah, there's probably a good reason for it. So obviously there's different types of books, so not all of them are going to be the same way. But like for cooking books, you only need to have 1 page of information, which is super easy to generate, right? Even though it might give you the wrong recipe or something. Other books are more difficult to generate because they're so long. And previously there was this limitation. I mean, there still is a limitation on the number of output tokens that a model can put at any one time. So previously, most models had an output limit of something like 4,000 tokens, is like a few pages of text or something. But recently, I think it was OpenAI that announced that they had a 64,000 token output limit for one of their models.
Whoa, okay.
Which is like 300, I think they cited as 300 pages of information.
Oh my God.
I don't know how accurate those 300 pages of information are going to be, and whether or not you would like logically be able to fill up 300 pages of information, or how logically internally consistent that output would be. But I can definitely see that access to a model like that is going to make it really easy for people to generate long content. And even if it's low quality content, I mean, you can put anything on the internet. You can sell anything, and you can make an ebook in 10 minutes, which means I don't know.
The moral implications of that may be
the implications are we'll probably see a huge wave of AI generated novels or novellas or something.
Yeah, that'll be interesting.
And whether or not that will catch on as a category of media, or whether people will be able to tell the difference, I'm really interested to see how that goes.
Yeah, because some of the examples that I've been seeing floating online are ones that maybe would potentially be dangerous. And what I mean by that is, like, one example, just to say, is there was a book that was apparently, again, we don't know, but apparently generative AI written content about foraging. And like, you know, I don't know, we're based in the Czech Republic. We know people like to pick mushrooms a lot. I would not want to buy that book thinking that I have a trustworthy source about, safe mushrooms and dangerous mushrooms. I wouldn't necessarily want to go down that path.
Right.
But if you don't know that it's, computer generated or AI generated, then it's harder to suss that information out when the author of the book looks like a legitimate author, the publishing company, whatever, and then all of a sudden you go down this rabbit hole and you realize, oh, this person doesn't actually exist. It's like an AI.
Right. And if you can generate realistic images that also trick people into thinking that it's not AI generated, then I can see where that could be a problem.
Listen, we tell you to generate responsibly in most of our episodes. We also want you to consume generated AI content responsibly.
Oh, for sure. Yeah. 100%.
So just, anytime we're talking about new technology and things, we always want to do our due diligence, right? And I think that just tends to be the moral of the story when it comes to generative AI, just generally speaking. Just do your due diligence, be responsible.
Think critically.
And maybe don't believe everything that you see on the internet, even if it has 5-star reviews or something like that.
Right.
So I actually think that's a great hopeful note to end this episode on. Thanks, Brandon, for telling us of all the cool new things that are happening. And
thank you.
We'll try to have these types of episodes for you all pretty frequently so we can really stay on top of what's happening in Gen AI. So thanks for listening, and tune in next week. Thank you for listening to The Generative Edge, a Deloitte Central Europe and AWS production. Your hosts are Brandon Eichner, Vyasaraj Kulkarni, and Donovan Sprunk. Our show is executive produced by Stephanie Cohen, Von Schluthra, Ian Masters, and the Deloitte studio in Prague. Head writers are Stephanie Cohen and Brandon Eichner. Our sound and audio engineer is Wojtek Krasa, who also serves as our editor and videographer. Michal Trusina is our graphic designer. Our marketing and social media managed by Stephanie Cohen and the Deloitte studio in Prague. And our theme song was written and produced by Jakub Vlašek. Don't forget to rate and subscribe on Spotify, Apple Music, YouTube, or wherever you get your podcasts. Thanks for tuning in.